of students think chapter 7 is going to be the hardest chapter, okay? And it's because of all the formulas. 7.1 is fundamental identities. So all of these formulas that you see are kind of like building blocks, things that we will use to figure out problems and answers and different other equations and things like that. So if you want to pause it so you can get all these formulas down, do so now. We're going to start with example 1. And example 1, you've actually seen this kind of problem before. All right, now I'm going to show you a different way of doing it. The last time, we did this problem, we drew a picture. And so, when you see tangent theta equals -5/3 and theta is in quadrant 2, what we did was we drew a picture in quadrant 2. I don't know if you remember this. Chapter 5 we did some, and chapter 6 I believe we did some again. But we draw an angle in the second quadrant, okay? And since we know tangent is y over x, we could fill in the y side of the triangle and the x side of the triangle. And then we could do Pythagorean's theorem to find the hypotenuse, and we call that r. Then we have this formula. It was 5 squared plus -3 squared. That's 25 plus 9. We've got the square root of 34 there. That hypotenuse is the square root of 34. So when part A says they want to find secant, okay, we know secant is 1 over cosine theta, or the reciprocal of cosine theta. And you should be able to see in this picture that cosine theta is -3 over the square root of 34. Okay? It's x over r. And so if secant is that reciprocal, then take that reciprocal, you're going to get -square root of 34 over 3. That would be the answer. Okay? That would be what secant theta equals. And we've already done this. Okay? We just did it geometrically by drawing a picture. I hope you guys remember doing that. Okay? Now, that being said, that's not what this chapter is about. And so we're really not supposed to be drawing that picture. We're supposed to be using those identities. Okay? And so, in order to use those identities, you're looking at what you know and what you want to know. If I know tangent and want to know secant, we've got to go back and look at those formulas and try to find a formula that has those two identities in it, or has those two functions in it. And so, see how this formula right here, tangent squared theta plus 1 equals secant squared theta? We are supposed to use that formula. Tangent squared theta plus 1 equals secant squared theta. We're supposed to use this formula, not draw a picture. We're not supposed to draw a picture. We're supposed to use this formula. So tangent squared theta just means take this and square it. Okay? We want to square this thing. So if you square this, you should be able to do that in your head. -5/3, if I squared that, would be 25 over 9. So 25/9 plus 1 equals secant squared theta. Now we're adding fractions, so to add fractions you would want a common denominator. So let's change that 1 into 9/9. So we have 25/9 plus 9/9 is 34/9. So 34/9 equals secant squared theta. Now if I want to know what secant squared, if just secant theta is, I'm going to take the square root of both sides, right? In order to solve this equation, in order to get rid of that squared, I do the square root. Okay, now the tricky part is, technically it's a plus or minus root. Okay, it's a plus or minus root. Remember how we always have the what and the where? The plus or minus is talking about where. So we have secant theta is going to equal plus or minus square root of 34 over 3, because that's the square root of 9, right? Okay, but at this step, this last step, you would say, oh, wait a minute, we're in the second quadrant. Quadrant 2, and what do we know about secant? Remember, secant goes with cosine. What do we know about cosine and secant in the second quadrant? It's negative, okay? So we would know that secant theta is negative square root of 34 over 3. So that's kind of a lot of work for something that we already knew how to do by drawing a picture. But that's what this chapter is about. We're solving the same problem, but we're doing it algebraically instead of geometrically.